Welcome back to Max with RP. Yesterday we have been exploring about polynomials using GeoGebra. We also found the relationship between the coefficients and the zeros of a polynomial. Today we are going to solve a few case study questions involving polynomials. A suspension bridge is a type of bridge which is hung below suspension cables on vertical suspenders, as you can see in the picture. And you can also see that the suspension cables are in parabolic shape. The point on the suspension cable just above the midpoint of the deck is the lowest point. This is the lowest point, and it is actually called the vertex of the parabola. And since this is a parabola, we have also explored a lot of parabolic polynomials, quadratic polynomials yesterday. And they are of which type? Ax square plus bx plus c represents a quadratic polynomial, and the shape of such a polynomial when sketched in a graph is a parabola. And in real life, we have an example here. Now, if the suspension cable is represented by the polynomial, let us look at the first question. X square minus 8x minus 20. Then what are its zeros? So one way of looking at it is you can just substitute each of these values and check whether it becomes 0. Because what is 0? What do you mean by 0 of a polynomial? The value for which f of x is 0. Suppose I call this equation as, say, p of x. Then when the value of x for which p of x is 0 is called as the 0 of the polynomial. The other way of doing it is you can actually split the middle term and solve. So the product should be 20, and you have minus 8x as a middle term. So I can write this as minus 10x plus 2x minus 20. This is x into x minus 10 plus 2 into x minus 10. This is x plus 2 into x minus 10. So what are the zeros? So the zeros are, when it is equal to 0, what are the values of x? The zeros are minus 2 comma 10. So minus 2 comma 10 is the solution. So this is the correct answer. Now, a second question. Let us read the second question. A quadratic polynomial, the sum and product of whose zeros are minus 4 and minus 12. You have to find a quadratic polynomial. What sort of quadratic polynomial? The sum of zeros is minus 4. Sum of zeros equal to minus 4, and product of the zeros is equal to minus 12. In my earlier video, we have also discussed that a quadratic polynomial can be written as x square minus sum of the roots. So here it is minus 4 into x plus product of the roots or zeros, which is minus 12. So this is x square plus 4x minus 12. X square plus 4x minus 12. So this is the correct answer. Is it clear? So either you can solve, or you can, by elimination also you can solve multiple choice questions. Now look at the third subdivision. A quadratic polynomial whose one zero is minus 2 and the product of whose zeros is 8. So let the roots be alpha and beta, or zeros be, let the zeros be alpha comma beta. Now 1 0 is minus 2. So alpha is minus 2. Now you have to find, and the product of whose zeros is 8. You have to find the other 0 also. So but what is given? Product of the zeros. So alpha beta is given to be 8. So what is beta? Beta is minus 4. 8 by minus 2, which is minus 4. Now you have to find a quadratic polynomial, okay, whose 1 0 is minus 2, that is alpha is minus 2, and the product of the roots is given, so we are also able to find beta. Beta is minus 4. So what will be the quadratic now? X square minus sum of the roots. What is sum of the roots? Minus 6 into x plus product of the roots. The product is already given, plus 8 equal to 0. So x square plus 6x plus 8. When I equate it to 0, it becomes an equation. Since they have asked only a polynomial, we can just leave it at x square plus 6x plus 8. Fourth question. A quadratic polynomial whose zeros are reciprocal of the zeros of this polynomial. What is a given polynomial? 6x square minus 7x minus 3. Okay. So what are the zeros of this polynomial? Let me call this as p of x. Now the product of the roots must be minus 18 and the sum of the roots is 7. So how will I write it? So the product of the roots is 18. So I can write this as 6x square minus 9x plus 2x minus 3. This is 3x into 2x minus 3 plus 1 into 2x minus 3. This is 3x plus 1 into 2x minus 3. So what are the roots? Zeros are minus 1 by 3, comma 3 by 2. So, but this is not, we want to find a polynomial whose roots are reciprocals of this. What are the roots now? Minus 1 by 3 and 3 by 2. Roots are zeros. Now what will be the reciprocal of the zeros? It will be, reciprocals will be, what will be the reciprocal of minus 1 by 3? So minus 3 and 2 by 3. So minus 3 and 2 by 3 are the reciprocals. So what will be the sum of the equations? X square minus 3 plus 2 by 3 x plus product. What is the product? Minus 6 by 3, which is minus 2. This is x square minus 9 plus 2 minus 7 by 3 x minus 2. So when I simplify this, what will I get? This is x square plus 7 by 3 x minus 2 minus 2. So if I multiply throughout, what will I get? 3x square plus 7x minus 6. 3x square plus 7x minus 6. So D is the correct answer. If the parabola representing the quadratic polynomial touches the x-axis, ax square plus bx plus c, so what kind of roots will it have? So if the quadratic touches the x-axis, then what happens? It is not intersecting, it is just touching. Then what kind of roots it will have? The roots are real and equal, because it has got repeated roots. If it does not touch, the parabola does not touch the x-axis, it has no real root. If it touches the x-axis here at 2 points, it has got 2 distinct real roots. If it touches the x-axis at just 1 point, then x-axis is a tangent to the parabola, and that point where it touches is a repeated root. That means it is repeated twice and it is real. So the roots are real and equal. Is it clear? So this is an example of a case study where you are given a source, and based on the source of information, we are asking some questions. Let us us look at another case study. On May 20th, 2020, super cyclonic storm hits West Bengal. It causes widespread damage to West Bengal. Due to this, thousands of trees were uprooted and electrical poles were bent out. Some electrical poles were bent in the shape of a parabola as shown below. So a parabola is represented by a quadratic polynomial, which is what we all know. Now, based on the above information, we are going to answer these questions. Okay. Now, what do you observe from the parabola? It's a downward parabola. Okay. You are given the graph of a quadratic polynomial. I keep repeating certain points which are very important. The graph of a quadratic polynomial is always a parabola. So, this is a parabola. Now, what is the shape of the parabola? It is downward. In my earlier video using GeoGebra, we have explored the properties of the graphs of quadratic polynomials, and we saw that the shape is downward whenever in the quadratic ax square plus bx plus c, a is less than 0. So, a must be less than 0. So, this is the correct answer. A less than 0. Now, zeros of the quadratic polynomial represented by the parabola are. So, what are the zeros? You are seeing the graph. So, what are the zeros of the polynomial? Zeros are minus 4 and 2. Zeros are minus 4 and 2. So, this is the correct answer. By looking at the graph, you are finding the zeros. What are zeros? The point where the graph cuts the x-axis. Now, the quadratic polynomial p of x representing the given parabola. So, if these are zeros, what will be the equation of the parabola? So, sum will be minus 4 plus 2, which is minus 2. Product will be minus 8. So, what will be the equation? X square minus sum of the roots into x plus product of the roots. It's a polynomial p of x. If you equate it to 0, it becomes a quadratic equation. Otherwise, it's a quadratic polynomial. Now, this will be x square minus into minus plus 2x minus 8. So, x square plus 2x minus 8 is the polynomial. So, this is the quadratic polynomial. What is the value of p of x at x equal to 0? So, that is p of 0. What is the value of p of x when x is 0? So, substitute x equal to 0. You get only the constant term, which is minus 8. In ax square plus bx plus c, if I call it as p of x, p of 0 will be c. Because x square and x will become 0. So, it will be c. So, you have to also learn to think in general terms. So, p of 0 is minus 8. So, is this case study clear? It's just based on your understanding of graph, understanding of the representation of polynomials as parabola. We are going to do one more case study. Observe this graph. So, first let us try to understand the graph, then we will solve the questions. Okay. So, when you look at this graph, what do you observe? How many zeros are there? You have 1, 2, 3. So, observation. Three zeros. So, whenever you have 3 zeros, what will be the polynomial? What kind of polynomial will you have? Cubic polynomial. What is a cubic polynomial? Degree is 3. Right? And what are the 3 zeros? This point, and this point. So, you can see this. These are the 3 points where it cuts the x-axis. So, now let us try to understand and solve the problems. The number of zeros of the polynomial y equal to f of x is 3. Now the curve y equal to f of x represents a polynomial which is cubic. The highest power is 3, it is called as a, or the degree of the polynomial is 3, it is called as a cubic polynomial. Where does the curve intersect the x-axis? So they have given you different points. So it is intersecting the x-axis first of all at 3 points. So what is this point? Minus 2, 0. Then it is intersecting at the origin. And what is this point? 2, 0. So the curve intersects the x-axis at minus 2, 0, the origin, and 2, 0. So minus 2, 0, the origin, and 2, 0. So these are the coordinates where the curve intersects the x-axis. So what is the one root is the origin. 1, 0 is the origin. The other two zeros are minus 2, 0 and 2, 0. So these are examples of case studies. I hope based on the previous videos, you are able to solve these problems much easily. They are very simple. But if you have gone through my earlier videos, I am sure that that will help you to understand and visualize polynomials as graphs. A linear polynomial is a straight line. A quadratic polynomial is a parabola. A cubic polynomial has got a maximum of 3 roots and looks like this. This is called a cubic polynomial if the degree is 3. If the degree is 4, it's called as a biquadratic polynomial. I hope you enjoyed the session, and I'm looking forward for more such sessions with you. So until we meet next time, it's goodbye. I hope you will not forget to follow my channel, to subscribe to my channel, and also do not forget to like and share. Until we meet next time, goodbye.